Good morning, students. I welcome you all for the section Engineering Graphics. I am Munnadan, Assistant Professor, St. Joseph College of Engineering, Mechanical Department. In today's lecture, we are going to cover position of points in details. That's very important. In this, we are going to discuss why points are very important for day-to-day life, and how to locate the points, and how to convert these points from 3D view to 2D view. So these are the we are going to see, and also some more examples. So before going to the lecture, first we have to understand why we need to study about the points. That's very important. I think my slide is visible to you students. You can check here. Here I have shown some solids. You can see here this solid is a cube. This one cuboid. This one hexagonal prism. This one square based prism. This one tetrahedron, triangular prism. This one is sphere. This one is cylinder. This one is core. Why I have shown these solids now in points? Because the points are much more related to all these solids. So later we come to this slide. First we move on to the why points are so important. You can see here whatever you write on paper. First you start with points. For example, if I'm going to write A, I have to start with points. I have to start with points. For example, B, I have to start with point. So whatever you write on the paper, first you have to start with point only. So points are very important day-to-day life. Point has no dimension, which means it's not having length, width, breadth, or any diameter. It is zero dimensional object. Think how we have to mark the points. It is like just a point. That's it. Because it has no dimension. If you want to draw the line, you need 2 points. Then only we can draw the line. See, 2 points we need. See, point 1 and point 2. For point, we can give only one name. See point, for example, point A. For example, point B. For example, point C. For example, point 1. For example, point 2. So for points, we can give only single name. That's enough because a point. But when it comes to line, we have to go for more than one name. Which means we need minimum 2 names. For example, see this one A, B. Or you can give 1, 2. So for lines, we give 2 names, which means while starting a line, we need point. When ending a line, we need point. Which means we are marking names at the starting point as well as at ending point. That's why points are more important in day-to-day life. So as I told you, if you want to mark the line, you need 2 points. Then what about planes? To draw the planes, we need more than 2 points. Here I draw a triangle plane. Sir, I am audible now?
Yes, sir, audible, sir.
Yes, sir, thank you. So here I have drawn triangular plane. This is a triangular plane, just a plane, triangular plane. You can see here. So to draw the plane, we need more than 2 points. So for line, we need 2 points. To draw the plane, we need more than 2 points. Then only we can draw the plane. Plane is very important for the life. Why? We will discuss later. So for plane, see, we have to give more than 3 names, A, B, C. Or you can give 1, 2, 3. So to draw the plane, we have to give more than 3 names. Not only this one, we have square plane. I'm sorry. So A, B, C, D. We have a rectangular plane. C, A, B, C, D. We have pentagonal plane. See, the side is 5 sides. 1, 2, 3, 4, 5. Here A, B, C, D, and E. Which means you can see here we are marking the names only at the point. See here we have 3 points. 1, 2, 3. So you are marking 1, 2, 3. Similarly, you can see here square plane we have point 1, point 2, point 3, and point 4. Similarly, you can see the pentagonal plane, we have point 1, point 2, point 3, point 4, point 5. Which means at the end of each line, you will be having the points, or at the starting of each line, you will be having the points. That's why studying points are much important for day-to-day life. So as we discussed, to draw the line, we need 2 points. To draw the plane, we need more than 2 points. How solids are forming? You can see here I have the one triangular plane as we discussed, and one more triangular plane we will draw it. So this one we call bottom, this one we call bottom, and this one we call top. So this generally if it is base, we also call it as a base we call BAC. So which means to draw the solid, very important, to draw the solid we need n number of planes. Minimum we need 3 planes. See, this is a plane, this is a triangular prism. See, I drawn here, this is a triangular prism. To draw the prism we need one plane, this is called triangular plane. This is also triangular plane, 2 planes we have. Other than this, we need a rectangular plane. I don't know where to select the sketch, so okay, no problem. I continue with the sketch. See the rectangular plane. This is a rectangular plane. All 3 sides of the triangular plane will be connected to the rectangular plane to form the solids. That's why I have shown the previous diagram. We'll go to the previous slide so that you can have better understanding. See here we have the cube. What is the cube? Base is a square plane. It's a square plane. Bottom also square plane. To join bottom plane and top plane, we need square plane. So all planes are square. That's why we call cube. See in this one, you can easily see. I try to erase all those things. How many corners we have? Corner 1, which means point 1, corner 2, corner 3, corner 4, corner 5, corner 6, corner 7, corner 8. So we have 8 corners to form the cube. So A, B, oh these are sorry right, we have to give only capital name. I'm sorry. A, B, C, D. In top I give P, Q, R, S. This is solid. That's why points are very important. As I told you, to draw the line, we need 2 points. To form the plane, we need more than 2 lines. More than 2 lines to form the plane. See line 2, line 3, more than 2 lines. To form the solid, we need more than 3 planes. Note it, students. To draw the line, you need 2 points. To draw the plane, you need more than 2 lines. To draw the solid or form the solid, you need more than 3 planes. Planes, lines, points. Without points, lines are not possible. Without lines, planes are not possible. Without planes, solids are not possible. That's why the points are very important for day-to-day life. Is it? Any doubts in that, students? You can chat me. Any doubts till now? Still my voice is low. Anyone, can you answer me? Sir, can you answer me? My voice is low. One of the students has mentioned my voice is low. Clear, sir. Thank you, student. Thank you. Any doubts about points introduction here? Any doubts? Can we proceed? You can chat. Yeah, clear one. Clear. We can proceed. We'll further proceed. I'll move to the next slide. Yeah, as I told you, point has no dimension, which means point has no length, no width, no breadth. Similarly, point has no dimensions. It has zero dimension. Number one, that you have to be clear in points. Also, to be clear, for point we can give only one name. It may be a numerical or alphabetical. That's your wish. Okay. Now come to the points. What we are going to discuss in today's lecture. In today's lecture, we are going to discuss about three major parts. First one, location of the object. How to locate the object. Where to locate the object. How it will be. That we are going to discuss in first part. Second part, object. When you look at the object, it may be any solid or any line or any point. But in our lecture, object is a point. Third one, observer. Who is observer here? One who is going to draw the diagram is the observer. How is going to look at the object? That's we are going to discuss a third. Fourth one, we are going to discuss some numerical. We are going to proceed. So first one, we will discuss about location of the object. So you can see here, I displayed one picture. Can anyone elaborate about this picture in a single line? Anyone, please? Very good boy. First one is good answer. Yeah, this is projector. Simply we don't want to go for in physics term, dispersion, spectrum. We physics stuff will take later. So it's a projector. When you look at this projector, we use this projector for displaying few objects, few anything. That may be movies, that may be presentation, whatever it is. Clear? When you look at this LCD projector, do you think without a screen is worthy? Anyone? Without a screen, is it worthy? This LED display. No, very good. So, if you want to use LCD screen or LED screen, whatever it is, you need screen. So, the screen is very, very important. You can see here. Here, I have mentioned two diagrams for better understanding. It is not points completely. Remember, it is not points. Okay. For better understanding, I given this picture here. Here, a man is standing. No, 1 minute. My sketch is missing here. Yeah, I got it. Here, one man is standing. You can see here. So here we have mentioned observer. Infinite viewpoint. Okay. So we don't have any dimensions here. So one man standing. This is our object. This is our object. This observer wants to draw this object on a paper. For example, take paper. Generally we call plane. What we call? We call plane. A reference plane we call reference plane. You want to draw the object. So see, this one plane of projection is what? A reference plane. Plane of projection is what? A reference plane. You can see this observer seeing your object through plane of projection, so that you can draw this. See, take these 2 points. Let's take point A, point B. This line alone. See where you drawn? Point A, B. Here you drawn. This is A, B. Which means if you want to draw an object by seeing visualization, you need some reference planes. Where to locate, how to locate. Without, see, these reference planes generally are imaginary planes. It's not real planes, it's imaginary planes. So we need to know why we are doing that first of all. And see your second diagram where a picture the object is here. The object is before the plane of projection, so that you can draw here. The view may be enlarged or small one. It's not a problem. But if you want to draw any point, line, or any object, solids like a prism, pyramid, wall, sphere, cylinder, cone, whatever it is, you need some reference plane to draw it. Similarly, to mark point, to draw the point, we need reference planes. Without reference planes, it's very hard to proceed. That's only we are going to discuss how to locate the point, the location of the object. That's the first topic, right? The location of the object. So you can see here, I mentioned one diagram here. We are going to discuss about it in graphical method because for my graphical method shows something different. That's why I given a reference diagram here. So here we have two planes. This is one plane. This plane is called vertical plane. It's a vertical plane. So if you have any doubt, that vertical plane you can see in our this diagram. This green color diagram you can see. This green one vertical plane. Vertical plane. What it means? You take the LCD projector. If you project on the display, when you look at display, that is your vertical plane. Your screen is your vertical plane. In cinema theater, your screens are vertical planes. So that's why we take it, that's a vertical plane. The second one we have horizontal plane, which means I'm seeing towards my front, so that I have vertical plane. If I'm traveling in an airplane, if I'm traveling on an airplane, if I'm seeing top to bottom, then I need one more plane. That plane is called horizontal plane because we have two views. We have front view, top view. For the front view, we have vertical plane. For top side view, we have horizontal plane. I already told you these planes are imaginary planes. These planes are imaginary planes. These two planes, vertical plane and horizontal planes, are intersected at middle. Both are intersected at middle. You know, there is a line which joins your horizontal plane and the vertical. You can see here. You can see here. This is a line. This is a line. This is a line which joins your vertical plane and horizontal plane. You can see here. I'm drawing it. Can you see this one? Can you see this one? Anyone? Can you answer me? That green color line which joins your, yes, very good, very good, very good, very good. So the line which joins your vertical plane and horizontal plane is called a reference line. What we call a reference line. That's we give a name XY. This line we call a reference line. This line we call a reference line. Which separate a vertical plane and horizontal plane. Some people may say, sir, exactly it has to be joining middle, sir, or exactly it has to be front and back, sir. Whatever it is, no problem, because all these are imaginary. We imaginary planes. We imagine wherever the object you imagine, you draw it. You don't want to say exactly the horizontal plane and the vertical plane meet at middle, meet at center. Not like that. You have horizontal plane, you have vertical plane. The horizontal plane and vertical plane which joins a line we call reference line. And then these planes meets at middle. Now I come to the point. Okay, these are the imaginary planes. Then these planes are joined at middle. Okay, these planes space is there, no, above and below. That space is segregated in four segments. Just a minute, students. My laptop can't better. Just 1 minute time. Just a minute. Just a minute. I'm sorry. Yeah. Thank you, students. Sorry. Okay. Okay. As we discussed, these are the imaginary planes, and I told you the vertical plane at one end or this end, whatever is not a problem. As I told you, because we say imaginary one, we don't say it has to meet at the exact middle or what something. We don't want to say. But when these two planes intersected at middle, the space above and below, front and behind is segregated into four segments. That's very, very important. This is segment 1, you can see here. This is segment 1, this is segment 2, this is segment 3, this is segment 4. Also called as quadrants. This is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant. Why we are drawing like this? It's very, very important. Clear? As I shown the diagram, see, let's go to back and come, okay, so that better understand. See here. Here you can see one object standing here is looking at this object, and you want to draw the diagram or you want to project the diagram. We don't want to say draw. You want to project the diagram before his view. Just look at this is a plane. You want to project this plane before the object. But here you can see this observer, you want to project his object after the object, behind the object. Got it? Behind the object. That is why these two planes are segregated into four quadrants. You can see here. Which means sometimes I can see from here I want to draw before, after. I want to draw, let me erase all these things so that you have better understanding. Let me erase. Yeah, good. So if you want to look at your plane, vertical plane from here, if you have object at first quadrant, you will be projecting on the plane here. If the object in the second quadrant, you will be projecting this way. That's why we have the vertical plane. Similarly, if you have here, the same way we project on vertical plane. If we have on third quadrant, we will be projecting on the vertical plane. No doubt. If you are looking towards what? Left side. In case, why we have horizontal plane? In case the observer looking the object at the top, this way, the object may be here, he will be projecting on horizontal plane, or the object may be here, he will be projecting in the horizontal plane, or the object may be in third quadrant, horizontal plane, the object may be second quadrant, or plane. So object may look either from your towards left side or top. So that we have four quadrant: first quadrant, second quadrant, third quadrant, fourth quadrant. You may draw it anywhere as you wish, as you imagine yourself. See, if you are an engineer, you want to draw some object, you assume my object at first quadrant, you draw as per your wish. Or if you want, you place your object in second quadrant, you draw as you wish. Or you place your object in third quadrant, you draw as you wish. You place your fourth quadrant, draw as you wish. Nobody will ask. But sometimes, as per syllabus, as per requirement, we have to fix some quadrants. In India, generally we use first quadrant. In other countries, they use third quadrants. And most probably second, fourth we won't use. We won't discuss. There are some reasons. We move here. This is very, very important that I have to show. Can you tell me anyone the picture which are displayed in right side? This is 2D object or 3D object? Anyone? 3D. Very good. 3D. It's a 3D. It's not 2D. Because what is meant by 2D? What is meant by 3D? First you have to understand. 3D means where you can see more than 3 surfaces, which means you can see the front side surface, You can see the top side surface, you can see the left or right side surface. That's one we call 3D diagram. But if you're seeing only two surfaces, you're seeing only front and top, and you're seeing side and top, or you're seeing bottom and the side. So those can be called 2D diagrams. Here you can see in front I can see this plane, no problem. In top I can see this plane, no problem. In side also I can see this plane, no problem. That's why we call this is 3D diagram. This is not 2D diagram. This is 3D diagram. Okay. Let's come to a point. We are engineers. Okay. Now we know very well. Here we have observer is looking from towards our left side. When observer look at this side, we know this is our first quadrant. Already they mentioned here, so we don't want to write extra. Additionally, this is our first quadrant. This is our second quadrant. This is our third quadrant. This is our fourth quadrant. If you place a point here, somewhere here, I'm placing point here. Okay. The observer looking at this point projection will fall on vertical plane, and the other projection will fall on horizontal plane if the observer looking at top view. This is a point. Let's take point A will take. Clear? Okay, very good. Now you are engineer. If you give this diagram to the another engineer or any layman, because we know very well, right? The design and everything done by engineer, and it is go to the workshop where the workers only read the diagram and they do the production. So they have to understand what are you giving. If you give your drawing like this, it's very hard to understand. That's why what we do, we go for 2D diagram. So 2D means you can see here you have vertical plane, right? This green vertical plane. Check my pen. This is 1h will take. This is 1h will take. Only this h will take. Because only you can see this surface, front surface. This is a front surface. The other surface you see horizontal plane. This is your side surface, side view. So in vertical plane, we can take only this line. That is I mentioned here. See your left side diagram. This is vertical plane. This is a vertical plane. This plane is vertical plane. Oh, just a minute. This plane is a vertical plane. Only this line. Only this line. We know, right? To draw the plane, this is a rectangular plane. To draw the plane, we need more than two lines. But in that, I am taking only one line. That is for 2D purpose. Only this line we are taking. For horizontal plane, we are taking only this line for 2D case. This is the horizontal line. So just you rotate on your imagination. Just rotate. If you rotate the diagram around, it is a 30-degree inclination. You rotate up to 90-degree. If you rotate, this is our first quadrant. This is our second quadrant. This is our third quadrant, and this is our fourth quadrant. Oh, I'm sorry. This is our fourth quadrant. For example, now we come to a discussion. For example, I placed my point A on first quadrant. Is it? Am I audible now? Yes or no? Yeah, super. For example, here you can see we placed a point on first quadrant. So I place my object at first quadrant here. Clear? So this one, if you go to the any workshop, for example, any production team, if you hand over this diagram, what you will think of us? You will think of us bad. You don't know where this point is located. And even if you give it 3D, I mentioned it is 30 mm, it is 40 mm. What it means? The point is placed 40 mm front of VP. So for vertical plane, the point A is 40 mm distance. For horizontal plane, the point A is around 40 mm distance. like that we have to mention. So that's why whenever you have 3D object, any 3D object, if these 3D objects goes to the production team as 2D object only. That's why in point also we convert all 3D diagram into the 2D object. So generally what we take only just these two lines, not this diagram. What we'll take just just a minute, huh? Just a minute. I will erase all the things. We'll take just single line as a vertical plane. We have to think it's a vertical plane. This is horizontal plane. Can anyone tell me in our left diagram where is the reference line? Anyone? Where is the reference line? We need to have a reference line, right? When two points join, we call it as reference lines. Anyone? Where is the reference line? Origin. Very good, boy. Very good, boy. See, the line is both intersect. No, see, these are vertical plane. These are horizontal plane. Where is both the line meets? That is your reference line. So I already told you for point we can give only one name, no issue. But for line we have to give two names. That's why this is a line will give X and Y will give two names because a reference line. It's a line. Clear? So I move on to the next one. We have much to cover today. So already it's 11:50. We will do most. Okay. Now one topic is over. One topic is over. Which one is over? Location of object is over. So I already told you how to draw the object. If you locate, you can draw the vertical plane maybe behind or in front of. Horizontal plane may be above or below. This is the concept of this location of the object. Do you have any doubts in this? You can ask me. Where to place the object? And I told you, if you're engineer, it's your wish, you can place anywhere. But for regulation, for syllabus, for study purpose, there are some countries may use first quadrant, some countries may use third quadrant, some countries may use second, some countries may use fourth. We do not know that. But in India we use first quadrant. For US they use third quadrant. So as per our wish, our rules and regulations, our terms and conditions. As per engineer also, it's your wish. Other than this, you can ask any doubts if you have any doubts. If you have no doubts, we can proceed with the object. You can chat. If you have no doubts, you can say no, we can proceed. Yes, we can proceed, no? Very good. Okay. Next, I come to the second point. So first one is over, as you planned. Second one, object. As we discussed already, the object may be point. I'm sorry. The object may be point. The object may be line. The object may be plane also. Plane. The object may be solid. Anything it can be, no issue. Wait, I draw it better solid. Since I'm using my tab, it will like something bad, so don't mind. So this may be solid. You have straight line. You have dotted line. This is flat prism. This may be solid. Anything it can be. Anything it can be. It may be point. It may be line. It may be plane. It may be solid. All these are considered as an object only. Even if you go and stand, you become object. You place a pen, pen become object. You place an automobile car, car is an object. So anything, if you want to draw it, it can be considered as object. That's the topic, object. Object is over. Now observer, very very important topic, very important, observer. Because we are the observers. If you are drawing, you become observer. If I am drawing, I become observer. If someone is drawing, he become observer. The one who going to draw the diagram is called observer. Look here. As we discussed, we have two planes, vertical plane, horizontal plane. The line which connect to a vertical plane and a horizontal plane is called a reference line. It's named as XY. Now, you want to place an object. You have to look at the front view. As I told you, we told you, when you have a projector. For example, I display projector here. I display projector here. So I display projector here. Where this projection falls on HP or VP? Anyone? Where the projection falls on HP or VP? VP. Very good boy. Very good boy. When you place projector here, this rails falls on only VP. That's why I have the observer now. You can see here. I will bring the observer. Yeah, the observer here now. He want to draw the diagram. So let me take just a point. You want to look at this point. Point A. I am giving capital name because the original point. Point A. You want to look at this point. You want to draw it. So where this front view projection will take place on VP, directly it will place on VP. As I told you, this is just imaginary plane, we are assuming. Okay, so here I give name A. Very simple. If your object here, no problem. If your object here B is here, no problem. Because the observer here only. The observer is here only. He is looking at this side only. This falls on VP only. This is point B. The only difference, this object is placed above the HP. This object is placed below the HP. That is the only difference in front view. When you look at the front view, any object, when you look at the front view, any object will project on VP only. That VP might be in front of or behind, no problem. For example, I told you now, my A is here, it will project on here. My B is here, it will project on here. For example, your C is here, your point C is here. You want to draw this point C. You want to draw this point in front view. Again, this going to project only on your VP only. On your VP only. As an engineer, you decide either your reference plane, that is vertical plane. This vertical plane should be beyond the object or in front of the object. See, this is A, right? This is point A. This is a point A, right? You can see, if you consider this is your object A, your reference plane beyond the object. You see the C point. This is C point. If you want to draw the C point, if you think you can take the reference plane, which means vertical plane, in front of the object, as we discussed in previous slide. As an engineer, we can decide it's our own decision, no problem. But again I'm telling, there are certain rules and regulations we follow in India, there are rules and regulations follow in US. They decide where the reference plane should be. So you don't memorize anything. We use only first quadrant, we use only second quadrant. Don't memorize. You can use any all the four quadrants, no problem at all. But the norms may fix us to draw like this. That you have to understand. Okay. So now C point. Now you place the D point. It is behind the vertical plane. This is what front view. Always any object similar to your theta view only. With theta view, what LCD projector does, what our visualization does, we look at only front screen. That is your front view. Front screen is your front view. Always. Remember that one. Now come to the second one, top view. As I told you, right, we have only two views. One is the front view, the other top view. We have a side view, but we are not going to discuss now. We will discuss it later. Top view. In top view, you have to feel such that the observer is looking at the object from the top. See, if you are having point A at second quadrant, it will be placing on HP top view. If you are placing point B in first quadrant, it will be placing on HP top view. These are all the top view. These are all the top view. If you are placing an object behind the horizontal plane here, see, it will be again going to project on HP only. This object B again same, no doubt at all. So remember, if it is front view, we have to look at from the right side. If it is top view, we have to look at from the top. This both you should not forget. So now we have observer, we have the object at first quadrant. I will mention the object first quadrant. We don't want to go for box and all, just a point. This point P I am marking. Okay, you can see this point P is placed in first quadrant between VP and HP. You can see here this point 1 is in front, okay, in front of VP. That's what we call in front VP, in front of VP. The point P is placed, and you can see above the HP. Clearly, you can see above the HP. So point P is placed above the HP in front of VP, which means if you are in first quadrant, if you place any object in the first quadrant, that object will be above HP and in front of VP. This one you have to understand. Very, very important. Very, very important. Very, very important. Can anyone tell me, if you are placing object in the second quadrant, how it will be? Anyone? I am placing my object Q is here. Object Q. I am placing here Q. Tell me how it is now with respect to VP and HP. Anyone? Behind VP. Very good. Very good. Very good. That's it. Okay. And I don't know how about other students. Can anyone answer me? Previously this one has taken. I will go to the next one. The very interesting one. Okay. Now the second quadrant, again observer is coming in front only. This is a point Q. Again we know very well this point is placed behind VP, and above HP only. Because you know very well, right? The VP plane is here. The point is behind VP for east look, and it is above HP. Similarly, you can see a third quadrant. If you place the object here, I will take point F. You observe in front. Again, if you look at this point, you can see this point will be projected on your VP, so that the plane is front compared to the point in front. That's why we call it as the behind VP. We call behind VP. And you can see the horizontal plane is above the point. Yes or no? That's what we call this is below HP. So the point is placed behind VP and below HP in third quadrant. Similarly, our final one, fourth quadrant. Place the object here, mark as any name as B. If you are looking at your front view, you can see the B will be projected on our VP here, and you can realize the B point in front of VP only. You can see the object first, then only reference plane, as I told you. So in front of VP, the B is placed, and you can see as well the HP reference plane is above the point P. So that's why we call this is below HP. So I have marked all four quadrants here. I given name. So you just assume yourself, keep any one point in first quadrant, second quadrant, third quadrant, fourth quadrant, And look at these names which are given above HP in front of VP, above HP behind VP, below HP behind VP, below HP in front of VP. Just imagine, we'll go for some examples. Shall we look at some examples? You have to answer me. Can we? Yes, go. Yeah. First, place a cricket ball and which quadrant? Yeah, first quadrant. Very good boy. I placed cricket ball in first quadrant. Can you tell me how it is placed with respect to VP and HP? First one, tell me with respect to VP. How it is placed with respect to VP? With respect to VP. In front of VP. Very good, very good, very good. It is in front of VP. What with respect to HP? Above HP. Very good, very good, very good, very good. Above HP. So you're clear now, you're clear now, you're clear now. So the ball is placed in front of VP and above HP. Very good, very good. Next one, next example. Now tell me where the ball is placed. Very good, very good. Fourth quadrant. Very good, boys. Very good, very good, very good. Can you tell me with respect to VP? In front of. Very good, very good. In front of VP. What is respect to HP? Below HP. Good, 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 good. Below HP. Very good, very good. You are almost clear. I mean, we should not say bottom of HP. We have to say below HP. Huh? So always mark it your mind below, below, below. Next one. Can you tell me now? Second quadrant. Very good, boys. Very good, boys. The ball is placed at second quadrant with respect to VP. With respect to VP. Behind. We should not say back. Behind VP. We can use our normal English, no problem. But we should be careful. Behind VP. Behind VP. What about respect to HP? Above HP. Good, 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 good. Above HP. Very good, very good, very good, very good. Next one, we move to the here. Where the ball is placed? Third quadrant. Super. Third quadrant. How with respect to VP? How it is? Behind. Very good. Because the reference plane is front. Behind VP. What is with respect to HP? Below HP. Very good, very good, very good, very good, very good, man. Very good, very good, very good, very good. Okay, these are simple understanding about the location of the object. How observer looks at point, how we have to mark the points. Now we'll come to the naming. Very, very, very important, man. Very, very important naming. How to give the namings. Very, very important. And remember, okay, you have some 10 apples in a box. 10 apples in a box. I want to the apples are small. You can differentiate. Okay, you can easily differentiate a small difference between each apples. Small difference each apples. In a box, it contains 10 apples. Each apple has some different compared to others. Just think like that. Just think like that. And you are parceling that box, 10 apples box to me. Okay. And remember, you are taking an apple. You are looking at the apple. The same apple I have to take. I have to look at. What you will do for that? Can you tell me what you will do? Okay, just clear about it. You have 10 apples in a box. You have to parcel that box to me. You have 10 apples in a box. Each apple is different compared to the other apple. You have to parcel that apple to me, and you have to indicate this apple is this apple is this. So what you will do? See, for example, you're counting the apples. You're taking apple 1. You're taking the apple 1, for example, you take the same apple 1 I have to take after opening the box. So what will do? Okay, here I'll draw. Okay, here I'll draw. So better understanding. 1 apple, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 apple you have to parcel to me. You have to parcel to me. For example, you are taking this apple, okay? The first apple you are taking. You are seeing, you are telling that this apple is 10 days older. 10 days older. Apple 2 is 20 days older. 20 days older. Apple 3, 30 days older. Like that, you are calculating. For example, calculating. You are passing the apple such that I have to be known. I have to be known. The first apple is 10 days. I should not say this apple 10 days older. I should not think like that. It's very bad. So what you will do? Very good, Samyukta. We have to sticker on it. What will sticker? First you tell me. What will sticker on it? Namings, very good, very good. We have to give the namings. Very good. Assigning some name. We have to say, for example, this apple 1 or apple A we can take, or apple B will take C, D, E, F, G, H, I, J. We can take. We have to give some labeling. We have to give some namings. We have to assign something so that when you parcel those apples to me, I can take same apple. I can tell to my customers this apple is 10 days older. This apple is 5 days older. Like that, I can tell to my customers. Which means namings are very important. Now you can understand. Yes or no? Tell me. Namings are very important. Yes or no? Yes. Namings are very very important. So when you give diagram to the production team, they should know either diagram is top view or front view. Very very important. Front view or seeing from side view also. Side view. Your production, your designer, your engineer, you're going to just design. You're going to just design. You're going to tell these are my conditions. These are my diagram. You do some product. You do to me. Later you're saying to them. But production team doesn't know because you're not there. Because you are designing in Chennai. The production team may be Coimbatore. The production team may be Delhi. The production team may be Bangalore. They may be in America. They may be United Kingdom. You will not know where they are. But once they look at your diagram, they must understand this is front view, this is top view, this is side view. Like apples. For that only, whenever we look at front view will give always dash name. Check here, dash name. Whenever look at front view, for point we'll give dash name. For top view, normal name. And for side view, it is double quoted name, A double dash. So A is for top. A dash is for front. Kindly, please, remember. And A double dash is for side view. You have to memorize. When you draw, definitely have to mention this without any fail. Have you understood about this? Have you understood? So front view, definitely A dash, B dash, C dash, 1 dash, 2 dash, 3 dash. Top view, just A, B, C, 1, 2, 3. Side view, no, A double dash, B double dash, C double dash, 1 double dash, 2 double dash. Like that you have to mention without fail. This is what your marks, this is what engineering. If you draw the front view, if you mention the only A and V mark, reduce 1 mark, 2 mark, it must be A dash. As an engineer, you have to understand that. Okay. You can see here we have a cricket ball, right? What is the name for cricket ball? Here we have a cricket ball. You can see here. What is the name for this cricket ball? Anyone? What is the name of? Yeah, very good, very good, very good. No, no, no double, no quote and all, no quote and all. Okay, no quote and all because it's a side view. I agree. We are looking from side view only. This is a side view only, but no double. I didn't say. Okay, it's just a A, capital A. Very, very important. Very good. Who is that? Johnny. Very good, very good. It's a capital A. And one more guy. Who is that? First one fellow's given name. AML, I can see only AK, not some more. So very good, very good, very good, very good, very good, very good, very good. So remember, why capital, sir? Very good, boy. Very good. Why small? Why not small? A? Very good. Okay, very good. For example, I'll come to your point. You have the object. When you give the design, this is your design. Okay, design sheet will take. You'll be having 3D diagram here. For example, my 3D diagram is a square plane. It's a square plane. Square plane. This is my square plane. Okay, this is my square plane. So I'm giving my square plane this dot. Okay, this dot. Okay, this is dot. I'm giving capital A. This column I'm giving capital B. This column I'm giving capital C. This column I'm giving capital D. I'm giving to the production team. So in this, our front view will take. General will take. This is our front view will take. I mentioned arrow mark. So my present team, I'm giving them a front view. What is my front view? When you look at plane, what will be the front view? Only line, as what I seen reference point. So you guys look. You have a C point, B point. So I mark C here. I mark B here. This is C. This is a B. Okay, 2 points I mark. Here, if I mention capital C, capital B, now tell me whether your product is line or plane. Tell me. It's a design sheet. Now, what our production team will think? Your product is line or plane? Now, product is line because it's a capital letter. If we give this is small letter, small b. If you give, now what the production team will think? What is the product? Anyone? Plane. Very good, boy. This is why we are using small letters. I understood why we are using small letters. I understood why we are using small letters. Yeah, very good. Henry Sam, very good. So this is why we are using small letters. Oh, Ritma. Again, I would explain. Yeah, I'll tell you. Plane. Very good. I go for rectangular plane. This is the best example I can give. Rectangular plane. So we have four corners. A, B, C, D. Now this is your product. You want to design a plate. For example, take rectangular plate. This is a plate. P-L-A-T-E. Plate. Rectangular plate. We call plane also. Rectangular plate. This rectangular plate we have to design. Okay. So telling to production team, the rectangular plane contains this much distance, this much everything. We're telling. For example, this is height 10 millimeter, which is 5 millimeter. You need a rectangular plate. Okay. So you give names also. You mention A, B, C, D. Also you mention, and you need front view. I'll just put FV. Okay. I'll just put FV. This is front view, and I also need top view. How it looks from top view. So front view, this is observe looking from this side, right? C and B only visible. This is C, this is B. I mentioned capital C, capital B. This is top view. I mentioned here. So top view means observe looking from the top. We have D and C. You can see here everything capital letter. What production team will think? I will I'll just erase. Okay, it doesn't know either you're going to design or going to manufacture plate A B C D, line CD, or line DC. He will never understand which one he has to manufacture. Either you want to manufacture line or you want to manufacture plate. He will get confused. That's why what we do, see, very simple. C dash, B dash. This one, small d, small c. So now we can say without mentioning anything. Can you say what is C dash B dash? What view that is? C dash B dash. What view? We can say this is front view of this plane. And DC what view? DC what view? Top view. Now we can say the DC is the top view of this plate. So that's why we are using these names. Clear? So very simple. So we use small letter A dash, and A double dash. I hope you understood about namings. Have you understood about namings? Why we are using A dash, A double dash? You can proceed further. Yes, very good, very good. Thank you, thank you, thank you, thank you. We proceed further. Okay. So as I told you guys, in India we use first angle, and we proceed first angle. You don't ask any questions why you use first angle, sir. Why don't you use third angle, sir? You don't ask, okay? So we use first angle. In India we have high standards, so for that we use only first angles. So observer in front we are placing the ball. Can anyone tell me where front view will be projected? VP. Very good boy. The front view will be projected on VP. Yes, is projected no? Is projected on the front view? What name shall I give? What name shall I give? First quadrant. A dash. Very good. A dash. A dash. So we give name A dash. Do you have any doubt in this? Do you have any doubt? No. Super. No. Super. Now look at the top view. Look at the top view. Okay. I have to. I'm sorry. Just a minute. Forget this man. You just think there is a man standing like this. Forget that man. Okay. Look at the top view. So where the office will be projected? HP. Very good boy. Very good boy. Very good boy. The other will be projected on HP. Do you have any doubt in that? No. So the name will be given. What's the name? What is the name will give? Yeah. Very good boys. Very good boys. Very good boys. Yeah. So clear, right? The projection is clear. The projection is clear. Yes. Super. Now it is 3D or 2D. The object what we are seeing, 3D or 2D? No man, I told you 2D means you can see only two surfaces. Yes, it's a 3D. We are seeing three surfaces. Is it possible to give this diagram to the production team? Is it possible to give this diagram to production team? No, very good boy, very good ma. No, we can't give because they will confuse. So how we have to give to production team? In what ma? 2D. Very good. We have to give in 2D. That's why what I do, look here. And this is my front plane. I'll take this front plane. It's 3D. It is 3D now. It looks like something different to you guys. I will take this plane. Complete plane I'll take. I've seen a mark in red color. Yes, see that one we are going to draw here. and in middle we have x, y. Have you understood? I replace the 3D to 2D. Yes. So just this plane it came down. This is HP, this is VP. Very simple. This is HP plane, this is VP plane. Do you have any doubt in this? How to convert 3D to 2D? No, very good. Okay. Now tell me, we have this cricket ball. I placed here. I given name capital A. If I give 2D, for example, I am marking here somewhere. Here I am marking. Front view, what's the name? It's a dash. Top view, it's a. Now tell me, I given to the diagram to the production team. Is it possible for production team to manufacture this cricket ball? Just think, is it possible? Just think. Very good, ma. No. Do you have any idea about why no? Do you have any idea about why no? I'll tell you. Yes, size also another matter here because a cricket ball size matters. But if it is point, no size matters, right? Let's assume only point, no, not cricket ball. If it is cricket ball, size matters. Now just a point, no matters, right? No, because point has no dimensions. See, the problem is we need to know where this cricket ball is placed, which means how much distance from the VP, how much distance from the VP, how much distance from the HP. This is very important, very important from the HP, because it's a cricket ball, no problem. You are giving some diagram, some hexagonal, some pyramid, prism, like that you are giving. We need to have the distance. Okay, without distance we cannot mark to 2D, because see, I'm not A dash here. Why can't I make A dash here? Why can't I do A dash here? Why can't I mark A here? Why I can't mark A here? I understood what I mean. Yes or no? Yes, so we need distance. Okay, I am marking this cricket ball 20 mm in front of VP. So the cricket ball in front 20 mm for the VP and 40 mm and 40 mm above HP. Okay. Now just to clear students, the observer is standing here. Now this observer is standing here. Okay, the observer is standing here, is looking from the front. Tell me, for him, which distance is visible? This 40 mm is visible or 20 mm is visible for this observer? I need, yes, what? Just clear. If he seeing from front, how much is visible? 20 mm is visible, 40 mm is visible. Okay, I'm drawing here. One man I'm drawing here. Okay, I place cricket ball here. Here the plane is here. 20 mm is behind here. Will 20 mm is visible to him? This distance is it visible to him? The cricket ball will hide, man. No, the cricket ball will hide. No, the cricket ball will hide. It's not visible. Clear? See, if I mark a line here, you can clearly see a 40 mm, right? Yes or no? God, the 40 mm is visible in front view only. The 40 mm is visible in front view only. Okay. If the 40 mm is visible in front view, where is vertical projector? Vertical plane, horizontal plane. It is visible in front view. Just think. 40 mm is visible in front view. I already told you we are seeing movies in front view only. The LCD projectors are displaying in front view only. So front view means we have to project everything in vertical plane. Very good, in vertical plane. So this 40 mm will be on vertical plane only. Very good. So where VP, the VP is here. So from here, the point is 40 mm. The point is front view only, A dash. This 40 mm is visible in front view only. On VP only. What about this 20 mm? Where you can see this 20 mm? In which view? 20 mm. In HP, in top view, very good. So here you have only a 20 mm. I understood how dimension should be given. Have you understood? Have you? Yeah, super. If you have any doubt, you can ask me. Okay, it's almost 12:30. I don't want to extend because it's lunchtime, I think so. So you can ask me any questions. We have 5 minutes questions. 12:30.